All right, welcome back, geometry kiddos. We are now on lesson 9, so it's kind of funky. We're doing lesson 9 after lesson 7, so you kind of just have to go with it with us, okay? So follow in your packet and follow the steps. Write in what we're writing in to help you out, okay? So this little unit is about parallel lines, okay? So the converse of corresponding angles postulate. If two lines are cut by a transversal, so a transversal is a line that goes through two parallel lines. So that is a transversal. Okay? And then these would be my parallel lines. All right? Parallel lines never touch. Okay? So there's corresponding angles are congruent, then the lines are parallel. So we're talking about parallel angles. All right? So what I would do is I would use a highlighter. 1, 7, 3, and 5 are all congruent. Okay? Those are congruent angles. In the same aspect, 2, 8, 6, and 4 are congruent. All right? Let's look at our outside. The outside of the parallel lines, these are called exterior angles. These are 1 and 8 are exterior, and so are 4 and 5, exterior. They're on the outside of the parallel line. So that would mean that these 4 angles are interior. Okay? All right, so like I said, if you look, 1 and 3 are congruent. Look, they're the same color. 1 and 3 are congruent. 2 and 4. Look, 2 and 4 are both green. All right, 5 and 7. 5 and 7 are yellow. 6 and 8 are congruent. Therefore, A is parallel to B. Line A and line B are parallel because their angles are congruent. So that's postulate 213. All right. Now let's look at these ones. Alternate exterior. So angles that are exterior and alternate, meaning on either side of the transversal, if they're congruent, therefore the two lines are congruent. So if 1 and 3 are congruent, then P and Q are parallel. Let's say there are angles 4, or let's just do angle A and angle B, okay? If angle A is congruent to angle B, therefore, P is parallel to Q. That's another one. Those are also exterior. So look, they're on the outside, and alternate, meaning they're on either side of that transversal that cuts through the parallel line. Consecutive interior angles converse. So interior, folks, inside the parallel lines. They're inside, and they are consecutive, meaning they're on the same side of the parallel lines. Supplementary. What does supplementary mean? They mean that they add up to 180. Okay? So if they add up to 180, that also can prove that P and Q are congruent. Okay? So let's say that I have 70 degrees here and 110 there. Does that add up to 180? Yes. So 70 plus 110 equals 180. Therefore, P is parallel to Q because they are on the same consecutive interior angles. That's also known as same side interior, okay? It's on the same side of the transversal. So alternate exterior are congruent. So if angle 1 was 60 degrees, so would 30. 30 would if angle 1 is 60 degrees, angle 3 is 60 degrees. Okay? If they're on the same side, they have to add up to something. If they're alternate, they equal each other. Okay? So going back to what you learned last time about angles, are they equal to each other or do they add up to something? Now let's look at the next one. Alternate interior. Alternate interior means the inside of the parallel lines. So 6 and 8, if they are congruent, therefore P is congruent to Q. Okay? Well, let's say if I had a star and a heart on these two angles, so if they were the angles right here and right here, are they on either side of this transversal? Yes. Are they on the inside of the parallel lines? Yes. So if angle star is congruent to angle heart, then P is parallel to Q. Okay, so we're going to use these ones, and I want you to draw this in your notes. Just draw it somewhere in your notes, and let's practice, and you're going to tell me which theorem you would use to solve it. Okay, so let's actually make 3 small ones. All right, I want you to draw these 3 examples in your notes, and then you can put them right next to the theorems. So put them right next to these theorems in your notes, and then we have to determine which theorem is it. Okay, so I drew a different example of parallel lines. So remember, this is the interior, and this is the exterior. Okay, this is the interior, this is the exterior. So exterior is on the outside. Okay, so let's look. Again, these are interior, and then these angles would be the exterior. Okay, so parallel lines, what's on the inside? Okay, parallel lines. Okay, and then that transversal cuts through it. Okay, cuts through it. All right, so look at them. So look at these angles and figure out which theorem is it. Well, these are on the same side of this line. They're on the same side. So this is called consecutive interior angle converse. So 2.21, consecutive angle converse. If they add up to 180, okay? So if these two add up to 180, therefore you could prove 2.21 consecutive angle inverse. So I'd have to say angle square plus angle triangle equals 180. All right, let's look at this one. So both of these angles are on the outside. They're on the outside and they're alternate. So that means that it's 2.2 or 2.20, and that's alternate exterior angle theorem, which means that these are congruent. So angle swirl is congruent to angle trapezoid. Therefore, these parallel lines are congruent. So let's make this line A and line B. A is parallel to B. Okay, so the first one was consecutive angle converse. Sorry, going back a little bit. The next one is alternate exterior. So if swirl is congruent to trapezoid, let's call this angle M and N. M is parallel to N. So you're using the angles to prove if the lines are parallel or not. Again, proving things based on the information you know. All right, these two are on the inside. They're interior, but they're alternate. They're on different opposite sides of the transversal. Okay, so if angle heart is congruent to angle circle, what does that mean? That means that these two angles are congruent. So let's make this Y and Z. That means that Y is parallel to Z. All right, so getting more examples on how to solve this. All right, back to the notes. Another one, perpendicular transversal converse. In a plane, if two lines are perpendicular to the same line, then they are parallel. Okay, so if P is perpendicular to R and Q is perpendicular to R, then P is parallel to Q. Why? Because if these make 90 degrees, that means that they are congruent. These two angles are congruent to each other. All right? So that is so this symbol means perpendicular, which means it makes 90-degree angles. So that's another converse that you might see. All right, now let's identify parallel lines using this information. So this one is saying angle 1 is congruent to angle 6. Well, what is it attached to, folks? What is angle 1 and angle 6 attached to? All right, if angle 1 and angle 6 are congruent, let's just look at these two lines. So we're looking at this line and this line, okay? Now, if we look at those, 1 and 6 are on the outside. That means alternate exterior. Alternate exterior. Okay? So that postulate or that theorem is 2.20 because it's on the outside. So if angle 1 and angle 6 are congruent, that means line L is parallel to line N. It has nothing to do with line M, just line N and L and N. Okay, now let's do the next one. All right, angle 2 and angle 3. All right, let's look at just those two lines. So I have this line and this line. Let's look at 2 and 3. If I just look at those two parallel lines, the 2 and the 3 are in the interior. All right, so let's look at my theorems and see which ones are alternate interior. So alternate interior. Okay. So if they're alternate interior, that theorem is 2.22. You can just write it, or 2.22 theorem. So if angle 2 and 3 are alternate interior and they're congruent, what does that mean? Which ones are parallel? Well, what lines are they attached to? They're attached to line L is parallel to line M. So looking at the information that's given to prove that they're parallel. How do I do it? By stating the postulate or theorem and then writing that they're parallel. All right, last one. In order to move in a straight line with maximum efficiency, rowers' oars should be parallel. So they got to be parallel in order for them to row correctly. Is it possible to prove that any of the oars are parallel? Well, how could we prove that? By using, do we have any information to prove that? All right, so it's kind of tricky to see, so I'm going to outline it. So we're looking at these lines of the rowers, okay? And we're seeing, is there enough information to prove that they're parallel? Well, we don't know anything about the angles, okay? So there's not enough information to prove that these oars are parallel, okay? So let's make an example that we could prove. All right, so let's pretend that, again, this is the row, and let's say that these are the oars. All right, so what could I prove to make sure to see that these two are that they are parallel? Okay, so what if I had angle 3 here, and I had angle 5 here? Okay, well, I could prove that those two are vertical, but that's not one of my theorems. All right, well, let's say 5 and 6. What if I said angle 5 and angle 6 add up to 180? Then I could say, oh, right, if 5 and 6 add up to 180, then I could prove that these two angles, so we could say angle D and F, D is parallel to F, based on that theorem. But just looking at a picture, you have to give more information in order to prove that they're parallel. So now it's your turn to practice and try out your homework. All right, have a great day.